So I guess we're making these for some reason. I don't know why, but for the past couple of years, I've been fascinated by the idea of making a pair of sneakers that I could actually wear. Not because I'm really that into sneakers, but because when I searched for the topic, it's been really hard to find anything that seemed like a reasonable weekend project. Maybe I'm just looking in the wrong place, but I mean, how hard could it be, right? Let's separate ourselves from the computer for this first attempt and try to put something together using materials I've already got. No 3D printing, no silicone molds. Just try to quickly put something together and establish some kind of a baseline to see if this is even a reasonable project. So let's start, and we're going to try and figure this stuff out as we go. I'm cheating and using these insoles that I got a few years ago but never used. We can make these too, but this will save us a lot of time. For the midsole, I'm using EVA foam. This is my exercise mat that's been gradually shrinking as I do stupid projects like this. So we draw a shape using our foot and the insole as a guide, and cut it out with a utility knife. Then we can clean up the edges with a sanding sponge. We'll want to raise the heel just a little bit to make it better for walking around. For this, I'm using 2 layers of thin EVA foam that will stick to the heel area. I'm just eyeballing the depth based on the curve of the insole. We'll glue these permanently later on, but for now I'm just sticking them together with some double-sided tape. Now we're going to stuff the midsole and the insole into an old sock that we'll be cutting up to make the pattern. This is what we'll be using in place of a last, just using my own foot. But a last isn't just the shape of a foot, it also has a bit of extra geometry in the toe box for the toes to move around. So what I'm doing is stuffing the toe area with a bit of extra material. Then we try wearing this, and in some places stuff a little extra material around the foot to fill out certain areas. This worked fairly well, but if I were to try this again, I'd wear a couple extra layers of socks just to add a small offset to the final shape. Now we begin the awkward experience of wrapping the sock with tape. I'm sure there are some people out there that'd be into this type of thing, but it's just a little weird. What this is going to do is capture the shape so we can then cut it out and make a flat pattern. One of the challenges here is that it will also capture how your foot is positioned, so it's best to keep your foot as straight as possible. Once this is all taped up, I cut it off my foot, and here we can see how it holds the shape pretty well. We can then cut off the excess fabric and tape up the cut line. Once this gets stuffed with some more material, in this case just more socks, this is essentially what we have as the last. Now we're going to start drawing the pattern onto this, starting by transferring the top of the midsole by filling it through the sock, also determining where I wanted to cut the top line. I decided to try making this a high top. I trimmed off the excess just to get a better sense of the final shape of the shoe. Now we can start sketching the design directly onto the tape. If for some strange reason you try doing something like this, I'd recommend spending a bit more time here than I did. There are certain parts of this that will overlap and will end up getting used twice on the pattern, so I'm drawing dotted lines to tell where to make the secondary cut after making the pattern for the outside pieces. It helped here to draw indicators of how these pieces fit back together. So all this stuff has been taken out of the sock, and now we can start cutting the pieces. Once these pieces are all cut out, we can start transferring these shapes to a sheet of paper. We'll want to leave at least a couple centimeters between parts of the pattern because we'll be offsetting these shapes for the seam allowance. Once these pieces of the pattern are done, we can tape this back together and trim along the other lines. Then we transfer these shapes too. We're also going to want to transfer our midsole. Then we can use a gridded ruler to offset these patterns by our seam allowance. In this case I'm using 1/4 inch. In retrospect, some of these lines didn't need to be offset given how some of the edges were finished in the end, but I figured it'd be better to have that extra material and trim it away if needed. So we just cut all these out. There's a couple more that we'll create later, but this is pretty much the entire pattern. I had some canvas material that felt like it was the right weight for these shoes. I think this is duck canvas or something. Although the weight of the material is fine, I wouldn't use it again. I definitely need to explore more on the materials on the next attempt. The pattern gets transferred to the canvas, then trimmed out with a rotary cutter. I also decided to make a backing for the tongue out of some fake suede. The back of the shoe needs some structure to it. Many shoes even put molded plastic pieces at the heel. We'll see what we can do just by adding some heavyweight interfacing. So what I'll do is start by cutting out a second layer of the back pieces. Then we make a couple new pattern pieces for the interfacing material, starting by tracing the non-offset versions of the back pieces, then offsetting inward by about 1/8 of an inch. And we'll use these patterns for the interfacing material. Now we have all the pieces we'll be using for the upper. Now it's sewing time, and some gratuitous B-roll footage. and we're going to start sewing these pieces together. I'm using black thread here mostly because it's more visible on video, but it also helps me figure out where I run into problems. For a cleaner look next time, I'll use the same color thread as the fabric. So I'm starting with the tongue, both the outside and the backing material, then these two pieces get sewn together. And we can continue building out the front part of the shoe. For a thick material like this, clips seem a little easier than pens to keep things together. This isn't the cleanest seam, I did better on the second shoe. The outermost piece was a little more challenging because of the tight radius in front. I decided to serge this edge, which in reality was kind of unnecessary. This project doesn't need a serger, in fact it kind of messed it up as you'll see later on. For the second shoe, I just ran a tight zigzag stitch around this edge and trimmed by hand. Then back on the other machine to finish up the seam. Now for the back part of the shoe, we're sewing the two pieces of each side together to form pockets for the interfacing material. Then we fuse it all together with an iron and use the edge of a table or something to help give it a bit of form. Then we stitch these two halves together. I'm also running a zigzag here for reinforcement. This will end up getting covered later. This might be the biggest mistake I made on this project. I thought it would be a good idea to finish these edges with a serger before covering them with the bias tape, but the radii of the corners were too sharp to pull off given the distance from the blade to the needle. For the second shoe, I just ran a zigzag stitch and trimmed it by hand. It turned out much better. Now we're going to attach some bias tape to these edges. I do have a bias binding foot for this machine, but it's pretty flimsy and doesn't handle thick materials or tight radii particularly well, so I'm just doing this manually. You'll see in the corners that it didn't quite cover the bad edges from the serger. The second shoe came out fine though. Then we can make another strip to cover up the seam at the back of the shoe, kind of acting like webbing, which may have worked even better, but I don't have any. I made this a little long so I could use it to form a loop to help pull the shoe on. I'm glad I did this because they are a bit tough to pull on. Now comes probably the toughest part of the upper, which is sewing the bottom piece on. We clip it all together and most of the front is fine, but the back part with the reinforcement is impossible, even with a zipper foot. So I found the best bet was to sew on the machine to the point where it got tough, then hand stitch the rest. It seemed tedious at first, but actually wasn't too bad. Since I anticipated this on the second shoe, it actually turned out alright. The final part of the upper is to add the eyelets for the laces, marking where they should go with a ruler and poking holes with an awl. Could have also used a fabric hole punch here, but I didn't have one on hand. Once the eyelets are in place, we can use eyelet pliers to make them grab onto the fabric. Alright, it's time to open up all the doors and windows, get away from the stove, and wear a respirator because it's rubber cement time. I'm using weldwood here because the smell doesn't stay around as long as barge. While the first couple pieces are drying, I'm covering the outside of the upper with tape. My history with rubber cement has told me when covering large surfaces, like we are here, it inevitably shows up where you don't want it to. So I'm just protecting the outside surfaces from getting ruined if that happens. Essentially what we're doing here is applying glue to both sides, letting it dry for 15 to 20 minutes, then sticking the two pieces together. And repeating that for all the layers we have. It's probably possible to cover all the surfaces at once and do this all in one go, but that just seemed kind of messy, so I did it in stages instead. While the upper and the midsole are drying, I'm also covering a strip of thin EVA foam. This will be used to fill the gap we'll have right below the upper. We'll see that in a second. We carefully pull the edges of the upper over the midsole and feel the inside to make sure it's bonding evenly. I'm taking some time here because once we apply force, it's stuck together for good. When this is together, this is where we see that gap I was talking about. So we fill that area with the thin EVA foam and trim away the excess. Since I wasn't paying attention, I now have to tape the upper again. This time specifically starting at the bottom because this piece of tape will determine the top of the outside rubber strip. I just found out that's called foxing tape. For this foxing tape, the closest analog I can think of was a dead bicycle inner tube that I kept around for some reason. Since this material is smooth, the surface needs to be roughed up in order for the rubber cement to stick to it. Some of this type of rubber has lead, so I'm still wearing a respirator while I'm doing this. Again, we apply rubber cement to both sides. Then once dry, we can stretch this around the perimeter of the shoe. Once applied, we can trim away the excess. For this one, it's important to use a fresh blade because we don't want to create a rough edge here. Then we can protect this with tape and move on to the outsole. This is the only piece I ended up having to buy for this project. It's called a soling sheet. I've seen them come in a few different patterns and cost around 15 bucks and can cover about 2 pairs of shoes. Again, we want to rough up this surface, apply glue to both sides, then stick them together after drying for 15 minutes or so. Then we can trim the excess material around the perimeter of the shoe. I don't have good footage of that, but a fresh blade will make quick work of it. So we peel off the tape and we have a finished shoe. Now we just need to make the other one. So it's the same thing, just flip the pattern over. This second one turned out a lot better. So now we've got a pair of shoes. Let's see how quickly it can be destroyed. So I put about a dozen miles on these in a couple days, so we can do a bit of a damage report. They held up surprisingly well. I was expecting something to delaminate, but everything seems to be holding together. They're also surprisingly comfortable, but I'd attribute a good part of that to using off-the-shelf insoles. A couple things I do notice is that this material seems to just absorb the dirt. I can't even brush it off. This material also wrinkles very easily. In the next round, I'd want to try some very different materials. Also, it seems like there are parts of the EVA foam that are compressed permanently. There may be need for some kind of reinforcement or perhaps experiment with different densities of foam. But they do function like shoes, so I guess that makes them a success, maybe? I don't know. So what's next then? I think that's really to start leveraging technology. If we had a physical and digital last that matched, we could start doing all kinds of crazy things, like making molded soles and structural elements and all kinds of stuff. So if I make another attempt at a sneaker, I'll probably start with that. Alright,